this lecture, I'm going to discuss about a very important topic of 8086. Most of the time, students are having lot of queries uh, from this particular topic of physical address calculation. So I'm going to discuss about the physical address calculation of 8086. Now, before going to the calculation part, I shall give a brief idea about the different segments and their corresponding registers uh, which are required in case of memory interfacing in case of 8086. Now, while doing memory interfacing, the memory unit can be divided into 4 segments. Okay, virtually it is divided into 4 segments. When we are interfacing a memory unit with 8086, the memory unit is virtually divided into 4 segments. The segments are code segment, data segment, stack segment, and extra segment. These are the 4 segments of the memory unit. Okay, and each of the segments are of 64 KB. Okay, you can access 64 KB of size in each of the segment. Okay, where these segments are present in the memory unit. Okay, now in 8086 also their corresponding registers are present. Now let me tell you once again, these segments are present in the memory unit. Their corresponding registers are present in 8086. What are the corresponding registers? For example, for code segment, the corresponding register is known as CSR, code segment register. For data segment, similarly, data segment register. For stack segment register. For extra segment register. So these registers are present inside the 8086 processor. Okay, and each of the register are of 16 bit, let me tell you. Okay, each of the register are of 16 bit. Now what they will contain? They will contain the starting address. These registers, this code segment register, data segment register, stack segment register, and extra segment register, these will be containing the starting address of each of the segment. Okay, now let me tell you, if this is the total memory unit and if it is having 4 segments, for example, code segment, data segment, stack segment, extra segment, each of the segments should have a starting address. Okay, and the starting address is present in the corresponding register of 8086. And other than that, every segment have some uh, offset register. Okay, every segment has some offset register dedicated for that segment. Okay, why these are present? To access each of these location of the different segments. So for each of the segment, 2 important things are there. You should have its starting address of the segment that will be present in the 8086 processor, and these are the corresponding registers, and you should have at least one offset register for each of the segment. Now for example, code segment, what is the offset register for code segment? That is known as instruction pointer, IP, instruction pointer. Instruction pointer. Likewise, for data segment, you can have base register BX, or you can have source index, or you may have destination index. So these are the 3 things basically used for as an offset register in case of data segment. Similarly, for stack segment, the offset registers are base pointer and stack pointer. So I am writing the short form, base pointer for stack segment and stack pointer. These are the 2 offset registers of stack segment. Segments segments has one offset register and some segment has more than one offset register. Okay. And so that's why for code segment only one offset register is there, that is instruction pointer. For data segment, three are there, that is BX, base register, or source index SI, or destination index. They are the segment registers of they are the offset registers of data segment. Likewise, for stack segment, base pointer and stack pointer. These are the two offset registers which are used for the stack segment. And similarly, for extra segment, the offset register is DI. So DI is applicable here as well as here also. Destination index. Okay. This is for extra segment. So I think hopefully all of you have understood the segment and their corresponding offset register and their corresponding segment register. So for each of the segment, you have a segment register and its offset register. What segment register will contain? The starting address of each of the segment. What offset register will contain? This location, currently which location you are accessing of each of the segment, that will be given by that offset register. Okay. So I think up to this much is clear to everyone. Now, how to calculate the physical address? Suppose if you have to access some memory location, okay, you have to access a memory location, you should have two important information. What is the data? What are the two important information you should have? You should have the address and its corresponding data. So to access a particular location, you should have the address of that thing, and for that only you need to calculate the physical address. Now, how to calculate the physical address in case of 8086? One formula is there. To calculate the physical address, in order to find out this address of a memory location, you should follow this formula. What is the formula? Physical address is calculated as segment register value multiplied by 10, and this should be a hexadecimal value. The 10 should be a hexadecimal 10. Okay. Then plus offset. Okay, this is the formula you have to use to calculate the physical address in case of 8086. What uh, what is this equation? What I told, segment register value, whatever the segment register value you have, that has to be multiplied a value of 10, and that index is H, hexadecimal index, and that result, multiplication result, has to be added with the offset value. Offset value means the offset register value for that particular segment. Okay. Now we'll see some example to uh, understand these things in a better way. So let's see this example. This is example 1. Assume the register values for data segment, the value is given, stack segment value is given, BX register is given, BP is given, DI is given, SI is given. For each of the following memory location operands, so four problems are given to me, given to us, and you have to find out the offset value as well as the absolute address or physical address. So see the first question, what it is given, SI plus 5. Okay. Now SI is offset register. Now if you can remember, what was the this corresponding segment register for SI? Okay, that for SI, just few minutes before we have seen, if SI is the offset register, its corresponding segment is nothing but data segment. For SI, the corresponding segment is data segment. Okay. Now, what we have to do? So in order to calculate physical address, you should have, if you want to calculate absolute address or physical address, you should have two things. One is the corresponding segment register, which has to be multiplied by 10 plus the offset value. So in this first question, as the offset is given as SI, you know SI corresponds to data segment, and data segment corresponding register is known as data segment register. Okay. So what is the value of data segment register given here? 2000. That has to be multiplied by a value of 10 to calculate the physical address, and that has to be added with the offset. Now in this question, what is the offset? Offset is SI plus 5. Now what is SI in this question? What is the value of SI given? SI is 0020. Okay. Plus this 5. So ultimately what is the value? This is 20,000 plus 25. So this is 20,000 25. Okay. This is the answer. Okay, and how to calculate the offset value? Very easy. Offset value is this part only, SI plus 5, that is 20 plus 5, that is 25. Okay, now do the next one. Part B, 12H BP plus SI. Now, if BP is given, if base pointer is given, then the corresponding segment is stack segment. Just now we have seen. So stack segment means we have to find out its corresponding stack segment register. And you know stack segment register value is given as 3000 in this question. So what do you have to do? As in this question, BP is given. Okay, I think some of you have this doubt, like if BP is given, so BP corresponds to stack segment, and along with that one, SI is also there in this question, and SI corresponds to data segment. Now which one to choose? Now you should remember one thing, if SI, DI, BX is given separately, then you should use data segment. However, along with SI, if BP is given, or DI BP is given, or along with BX BP is given. Now, if BP is there, then you have to select stack segment. You do not have any other choice. Okay. So if BP is given with along with something, then you have to select stack segment as the corresponding segment. Okay. I think some of you had that doubt. Now things are clear to everyone. So what you have to do, as my corresponding segment is stack segment, and stack segment value is given as 3000 in this question. So 3000 plus 3000 multiplied by 10 plus the value of BP. So in this question, the value of BP is given as 021B, 021B, and what else? SI is given as SI value is given as 0020, and another this relative value is given as 12. Okay, so this resultant will be the physical address for this particular thing. So what will be the result? Here it is 30,000 after multiplied by 10. Then here you have 0 to 1 B, and you have 20, you have 12. Now add it. So B plus 2, this is D. Hexadecimal addition only you are doing. 1 plus 2 plus 1, this is 4. Then you have 2, then 0, 3. And this result, this is the result. And how to calculate the offset? The addition of this part. The addition of this part is the offset. So that is 021B plus 20 plus 12. And this is nothing but 4D. So see, the offset result is this one. Now likewise, for the third case, BX comma DX. Now BX is nothing but, if BX is there, you know, it will indicate data segment and the corresponding register you need to take, and that is given in the question as 2000. That has to be multiplied by 10 according to physical address calculation formula, and it has to be added with BX plus DI. Okay, so the result will be, if you do the calculation, the result will be this one. Okay, and how to calculate the physical address? That is the BX plus DI part. So BX is given as 012 in this question, and DI is given as 0010. You do the addition, you will get that result. Now what about fourth part? BP minus 3. Now if BP is there, just few minutes before I told, it should be stack segment, and stack segment result is 3000. It has to be multiplied by 10 plus this offset value BP minus 3. So BP is 0 to 1B and minus 3 you need to do, and this is the offset value that has to be added with 3000, and this result is nothing but this one. So hopefully all of you have understood how to calculate the physical address in for such kind of problems. Now other than that, uh, you should remember this table while solving this kind of problem uh, when some instruction will be given. Okay. So from the instruction, you need to identify the addressing mode, and from the addressing mode, you need to do the calculation. Okay. Now, uh, this is the table you should remember. Now, register addressing mode means you no need to calculate any physical address. Why? So first, I am giving one example of register addressing mode. For example, move ex comma bx. What type of addressing mode is this one? Register addressing mode. Why? The operand will come from some register bx and that will go to ax register. Okay. So this register addressing mode. Now as value is available in bx, you no need to calculate any location through which you need to access the data. Okay. So that's why no need of doing any physical address calculation for this particular problem when you have register addressing mode. Now next one is immediate addressing mode. What is immediate addressing mode? For example, move ax comma 1000 h. What does it mean? 1000 h value you should take in ax register. Now, is it required to access any memory? Not required, because already 1000 is given in the instruction itself. That value you have to take in ax register. You no need to access any memory. You no need to check any memory. Okay. So that's why if immediate addressing mode is given in the instruction, no need to calculate any physical address. So basically, when to calculate any physical address? If any instruction is given in this format, like in this third bracket, for example, move ax comma in square bracket 1000 h. Okay, this is what type of addressing mode? Direct addressing mode. All of you know why the address is directly given in the instruction. So in such case, the default segment will be data segment. Now register indirect without giving this address, if it is given in register form, for example, move ax comma in square bracket bx. Now directly the address is not given. The address is given through register. So this is known as register indirect. Okay. So in this case, what should be my segment register? What should be the corresponding segment? In that case, if it is bx sidi, just few minutes before also I told, then by default segment will be data segment. Now base relative. What is base relative? Along with the indirect mode register, you should have some displacement. For example, move ax comma si plus 5. So along with the register, you have some displacement, or you can write it as bx plus 5, same, bx plus 5. So displacement is this numerical value, and both the things are coming inside this square bracket. Okay, this type of thing is known as base relative, either bx or bp if it is there. In that case, how to identify the segment register? Now, if a few minutes before I told you, if it is bx, the segment will be data segment. However, in the instruction, if bp is present, whatever may be the remaining thing, blindly you need to understand that you have to access the stack segment, and that will be the segment. Okay. Then index relative also, you know, index register will be there along with the relative value. For example, di plus 5 or di minus 5 or si plus 5, di and si, these are the index register. That's why this is given as index relative. Base relative means bx and bp. These are the base register you can use. Bx and bp under command. Now, I was discussing about index relative, that is di and si. And if you know, if you can remember, di and si, in both the case, the default segment is nothing but data segment. Okay. Now, base index relative. Base is present, index is present, relative means displacement is also present. If it is given as move x comma x plus si plus 5. So base bx is present, index is present, that is si, index register, and this relative address, relative value is also present, that is 5, for example. So in this case, you have to select data segment. Why? Because in this problem, bx is there or si is there. You have to select data segment. However, if b is there, any other register, that time what I told, if bp is there means blindly it should be stack segment. You no need to see any other thing. So if it is BP, you no need to see any other things. By default, you can select the stack segment. Okay, so this is the way you can identify from the addressing mode itself which segment you need to select to calculate the physical address. Okay, now we shall see some example based on this particular discussion. Okay, for example, this question is given to us. All the segment values are given in the question, and these are the instructions given to me. And this should be, for example, BX. DX is not actually possible, BX. Now, how to calculate the physical address in such a case? Okay, how to do that? So addressing mode part, I think all of you know, add AX comma in square bracket because this is register indirect. Register indirect. If I write BX means specifically which category of register indirect? Indirect. This is based addressing mode. Then MUL SI comma SI plus 70, that is base index register, no index relative, because SI is the index register and this relative value is present, index relative. Then BX is also base relative. Why base relative? BX is a base, it is a numerical value. So when numerical value will be there, relative term will come, base relative. Okay. CMP AL comma BL, this is nothing but indirect. No, sorry. It is given through register. So register addressing mode. Okay. CLD. No operand is present. It means it will be implied. So I think all of you know uh, this addressing mode. If you have not gone through my previous lecture of addressing mode, all of you should go there and check. I have discussed each of the addressing mode there, and in that case, you will get a better idea of the addressing mode. Okay. Now here the main discussion was to calculate the physical address. Now how to do that? Now in this problem, move AX comma BX. So what register is there? BX is given. Now BX is given means if BX is there, then the corresponding segment is data segment. Just few minutes before I told you BX is there, the corresponding segment is data segment. So what you have to do? For the first problem, add ax comma bx. So here bx means you have to take the data segment value, that is 2000 has to be multiplied by 10 because you are calculating physical address. Segment register value multiplied by 10 plus its offset value. What is the offset? Bx value. Check the bx value here. What bx is given? 2020. So plus 2020. Do the addition and that will be the physical address. So it is 20,000 plus 2020. So it is nothing but 22020. That is the address. Now do the second one. Second one is SI plus 70. So SI means in this case also you know if SI is there means then I have to take data segment. So same formula I need to use 20 into 10 plus SI value is given as 1223 plus this relative value is given as 70. So do the addition and calculate that thing. So this is 20,000 here and this if you add. Now let me tell you this should be a hexadecimal addition. So here it is coming 3, 7 plus 2, 9, this 2, 1. So ultimately 21293 if I have not mistaken. 21293 hopefully. Now do the next one. So the next one is move AL comma BX plus it is. So BX means again same thing data segment. So that is 20 into 10 plus BX value is given as in this problem 2020 plus relative value is given as 80. So if you do the addition, this thing 0, 8 plus 2 it is A, hexadecimal addition we are doing this 2 and that has to be added with this value. So if you do this addition ultimately 220A0 with the result. Okay, then next one CMP AL comma BL. So this is you know AL comma BL, this is a register addressing mode and few minutes before we have seen in register addressing mode you no need to do any physical address calculation. So this is to make you confused, that's why this instruction is given, no physical address calculation is required. CLD implied addressing mode, no need of any physical address calculation. Okay, so hopefully all of you have understood this particular lecture. Thank you.